Hello friends, welcome to GoodTecher LeetCode tutorial. Here we are going to solve trapping rainwater coding problem. So I'm going to solve trapping rainwater coding problem this time because I received a YouTube message from a friend John Wick. Please make a video on dripping water. So I'm guessing trapping rainwater is a coding problem he is asking for. So like this friend John Wick has a good name, John Wick. John Wick is a movie character played by Keanu Reeves. So maybe this friend John Wick is Keanu Reeves himself. Maybe Keanu Reeves, he's also doing some coding nowadays. Nowadays, people all try to learn some coding, learn some technology skills, and to improve with the future. So that's good. So we can take his request and solve this trapping rainwater coding problem. So given n non-negative integers representing an elevation map where the width of each bar is 1, compute how much water it's able to trap after raining. For example, given array of integers 0, 1, 0, 2, 1, 0, 1, 3, 2, 1, 2, 1, return 6. So here's a picture to help us understand the meaning of this problem. So the above elevation map is represented by array of integers. So this array of integers, in this case, 6 units of rainy water, blue section, are being trapped. So we can see here, we can perceive this like a blue squares. One blue square is 1 unit of water. So 1, 2, 3, 4, 5, 6. So that's total 6 units of water can be trapped. And those black squares, those are the bars. So the vertical line indicates the height of bars, and the horizontal line indicates the sequence of bars. So like the first bar, the height is 0. So if we're showing here, we don't see the bar with the bar here, but it's actually there's a bar here, a bar with a height 0. Second one, bar with a height 1. Third one, another bar with a height 0. Fourth one, a bar with height 2. Fifth one, a bar with height 1. So the goal for this problem is to find the total amount of water can be trapped by this whole group of bars. So the key point to solve this problem is to actually to find and build the relationship between the bar heights and the amount of water can be trapped. So here, follow me. I have some example to help you understand the process to solve this problem. So see here we have this input array that with 8 numbers. So 8 numbers indicates 8 bars and their heights. So the vertical line indicates the height of a bar. The horizontal line indicates the sequence of bar. So like the first bar, that's a height with a 2. And the second bar, that's a height with 1. Third bar, a bar with height 0. So if we are going to draw the picture of total amount of water can be trapped, we can use that separate line to indicate the water. So the total amount of water can be trapped by this group of bars would be like this. So there are 1, 2, 3, 4, 5, 6, 7, 8. Total 8 units of water can be trapped. So it's easy for us to draw the picture of amount of water, but it's difficult to find the relationship between the whole group of bars and the total amount of water can be trapped. So we need to change our idea to change from the macro perspective to look at this whole group of bars together to that micro perspective to just look at the individual bar, to look at the individual bar that how much water that each individual bar can hold, and then sum up the whole amount of water together to get the total amount of water. So we change our idea. We are going to, like, for each bar, we are going to get amount of water it can trap, and then sum up total amount of water trapped by each bar. So we change our idea. We change from the macro perspective to look at the micro perspective, to look at each individual bar to get the water. Okay, so to look at each bar, so what's the relationship between each bar and the amount of water it can hold? So here we can look at that each individual bar. So like for the first one, how much water can it trap? That's 0. Why is 0? Because on the left side, there's no bars anymore. So on the left side, it's the first one. So on the left side, there's no bar. So the water is falling down from the left side. But for the second bar, it can hold 1 unit of water. So why it can hold 1 unit of water? Because we find that on the left, it has 1 bar, and it's taller than its height. So we can get the like a difference between the left bar and the right this bar. That's just 1. Height 2 minus height 1. We get a bar. And we look at the third one. Third one, it can go to get the total 2 amount of water, total 2 units of amount of water. Why is that? Because its own height is just 0, and on the right side there's a bar with a height of 2. That difference is 2. So that we know that we should notice that for each bar, so the amount of water depends on the minimum of the left highest bar and right highest. So why is that? So like here, if we look at the index 2, this bar, height with 0, the total amount of water it can hold is actually based on the left highest bar and the right highest bar. So if we look at some, like the whole picture, that's the left highest bar to here is this bar. That's a 2, height with 2. And the right highest bar is this 7 index bar. That's height with 3. At the minimum of the left highest and right highest is a 2. So this 2, this is the left highest. We take the height from the left highest and use the left highest to subtract its own height. And then we will get the water amount. So this is a relationship between the height of bar and the amount of water can be trapped. So see, let's iterate that each bar and see this formula. So here, like the first bar, that height is 2, but we know that at the beginning because at the left side the height is 0, so that the minimum left height and right height is, no matter how high is the right height is, so left side is always 0. So that's 0, so that we can only get the water amount just 0. So the second one, because the left height is 2 and right height is this 7 index, that's a 3, but the minimum is 2, we get a 2, and the minus is a height, that's just 1, so we get an amount of 1, that's 1 unit amount of water. Third one, because the left height is and right height is left height is 2, right height is 3, we take the left height is that 2 minus its own height, that's a 2. And the 3 index, this fourth bar, this bar, we take the highest from the left highest, that minimum left between left highest and right highest, that's a left highest, that's 2 minus this own height, that's a 0, so there's no difference, so we still get a 0 amount of water. And this fourth index, this one, we take the minimum from the left highest, so left highest minus its own height, that's 2. And this one, fifth index, so this one, same thing happens here, so we get the left highest, that's 2 minus its own height, that's 2. And the sixth index, that's 2 minus its own height, that's 2 minus 1, that's get 1. And the seventh index, this one is the highest one, so left highest, right highest, so it's a 2. 2 is shorter than its own height, so we won't get any amount of water, so it can only get 0 amount of water. And 8.1 is the last bar, because the last bar on the right side, the highest is 0, so this one, no matter how high the left height is, it can only get the 0. So that we know that for each bar, the amount of water depends on the minimum of the left highest and the right highest, and we get the mean value between left highest and right highest minus this bar on its own height, and we get the water amount can be held by it. So we see that it's like each individual bar, that at the top, if it can hold some water, the water is always held at the top of each bar, so that if the bar can hold water, the total amount of water is at the top, and we get the total unit of water. So for the coding, what we can do to convert this ideas to a coding, we can do first from iterate that each bar to get the left highest value relative to the each bar and then we can do we can compare with the right highest with the left highest. We get the minimum of left highest and right highest, then minus its own height to get the amount of water it can hold. So here, this is the whole idea to solve this problem. So we convert the from macro perspective to micro perspective to look at each individual bar to get the amount of water it can trap and sum up the total amount of water that each bar can hold to get the total amount of water can be trapped by this whole group of bars. So here I'm going back to the coding to demonstrate coding in Java how to solve this problem. So here at the beginning, for this problem, we are going to return the total amount of water can be trapped. So we can call a variable like a total amount, and at the beginning it's just a total amount is just 0. So we can have a edge case check first. So if this input array is null, or this input array is an empty array, we are going to directly return this total amount that's just 0 at this point. And then, as we mentioned, we can first do iterate that each bar to get the left highest bar for that each bar to build an array that holds the left highest value. Left highest. And the length of this array would be this input array plus 1. Left highest. The first one would always to be the 0. And we are going to for int I minus height dot length I plus plus. So we start from the first highest. We are going to calculate that each bar's precision, what's the left highest value for each bar. So like here, so left highest, like because we iterate the current precision, we are going to calculate for the right side. So left highest is I plus 1 is mass of the left highest I compare with the left highest previous left highest and the current bar height. Then after this loop, we are going to get the left highest value for all the bars. And here we can have one variable called right highest. Right highest. So we can start from the right side. This is second iteration. So first time we get the left highest, and second time we start from the right side to compare with the left highest and the right highest. So I equal to height dot length is 1, and I greater or equal to 0, I minus minus. And we are going to update the right height. So right height at the beginning is always 0. So last one always 0. So right height max current height and right highest. and we are going to update the total amount. So we can have a if check. So if that the minimum of the left height and right height is greater than the current bar height, and we are going to add to the total amount. So here we can have a ternary expression to do this if check. So if mass.min that left highest for this I position and the current highest, their minimum value between these two values minus the current height value is greater than 0, and means the minimum of the left side and right height. There's a bar on the left or on the right is taller than the current height, current bar. We are going to add this value to the total amount. That would be the just this. Use this just greater than this current bar. Left highest I, right highest minus. So we use a difference. That's the amount of water it can hold. Otherwise, it's just a 0 amount we can add to the total amount. Then finally we can return this total amount. So let's quickly do a check if there are some typo. Left highest with this array, first one is 0, and then we iterate the bars first time to get the each bar that left highest bar to the each of the bar. And then again we do a right highest from the right side, right highest, and we compare with the left highest. So if a minimum between left highest and right highest is greater than the current bar, we are going to use the minimum of left highest and right highest. The difference between this minimum value minus this current high. Add this unit, add the amount of water to the total amount. Then otherwise, it's just a 0 unit of water it can hold. Okay, let's click the submit button. Okay, accepted. Cool. So we successfully get the right solution for this coding problem. So you see, this is a hard coding problem. So it's hard. It's not about the code. You see, the code is just less than just about 20 lines. So the code is not the difficult, but the difficulty part is to find the idea, the approaches to get from this information, from the problem's information to your final solution, like from this macro perspective to that individual micro perspective to look at the problem. So this is the hard part. And also for this problem, like if you want to see like a time complexity, so like time complexity for this one is just like there's one iteration just that's a linear, and for the space complexity for this problem, because here is an array that's based on the size of this height. So this relationship is linear. So for this coding solution, so the space complexity would be the linear ON. Okay, so I hope you enjoy watching this and get some idea how to solve this problem. So that's all about this trapping rainwater. So thank you very much for watching this video. Thank you very much for following and subscribe the GoodTecher YouTube channel. So let's make progress together and see you next time.